All right, this is negative 19. How did that go?
Yay!
It went okay? This is x is less than or equal to 3. This should be x is less than negative 2 or x is greater than 2. And this is how I wrote this out. Some of you probably did it in your head, but h plus 2h or 3h is greater than or equal to 30. H is greater than or equal to 10. You have to work at least 10 hours the first week. Let's try some of these then. All right, we have to realize that whatever is inside the absolute value brackets has to either be, guys, negative 15 or positive 15, right? So we need to find out what value of x will give me negative 15, and also what value of x will give me positive 15 inside there. Because there's going to be two values of x. One of them is going to give me negative 15. Oh, I'm sorry. Thank you. Okay? All right, so now I'm going to solve both to see the two values of x that will work in this particular equation. So I add 9 to both sides. I get 2x equals negative 6. Divide by 2. X equals negative 3. So I'm thinking this is going to be one of the solutions. Then I add 9. 2x equals 24. Divide by 2, x equals 12. Now I have to say to myself, I got to check for extraneous. So I take negative 3, go back to the original equation. 2 times negative 3 is what? Negative 6, take away 9 gives me what?
Negative 15.
Negative 15, the absolute value of negative 15 is 15, so that one works. 12, 2 times 12 is what?
24.
24, take away 9 is positive 15, so that works. So these are both good. No extraneous. All right, let's do one more. The value inside here could either be what or what? 20, right, negative 28 or positive 28. So I'm going to set up this equation, this expression, to be equal to negative 28 and positive 28. And I got to find out what x value is going to give me both of those. So you subtract 12. 4x equals negative 40. X equals negative 10. Subtract 12, subtract 12. 4x equals 16, and x equals 4. And then you check for extraneous solutions. Okay, let's look at this next one here. I got the absolute value of 4x plus 10 is equal to 6x. This is okay, it's just some number. I still take what's inside here, and I set it equal to negative 6x and positive 6x. And I got to solve it. So I'm going to just take and do this. Negative 4x, negative 4x. 10 is equal to negative 10x. Divide by negative 10. X equals negative 1. There's one of them. We'll try that in a second. Subtract 4x. Subtract 4x. 10 equals 2x. Divide by 2. X is 5. There's my other one. All right, well, let's just see what happens. If I stick 5 in, I get, what, 20 plus 10, that's 30, right? Absolute value of 30 equals 6 times 5, which is 30. That's correct, isn't it? That works. So this one works. Now if I take negative 1, I'm going to plug that right in here. equals 6 times negative 1. Wait a minute. What does 6 times negative 1 equal? Okay, stop right there. Whoa, Nellie. We got a problem. What's wrong with this? Can the absolute value ever equal a negative? No. So this one does not work. This one is extraneous. Finally, you get an extraneous solution. Doesn't have to go any further. The only solution is 5.
Whoa, Nelly.
That's right. 4, teacher, for algebra. Okay. I think in Butler's class, you kind of remember greater or less than. Okay. In Devers and my class, we did Gorland. Gorland. What? Gorland.
I don't remember.
Okay. When you're doing extra value, you might have had algebra here. Maybe they did something else. But somehow you got to remember a little way to remember how to set these up and to begin the solving process. So we used Gorland, which means if it's greater than, it's going to set up as an or. If it's less than, it's going to set up as an and. However you want to remember it. Greater, less than, okay? So, don't do this one yet, you speed demons, because I'm changing it. Just in case you can't stand it, I'm going to make that a less than. All right? So, let's start with this one. We have the absolute value of 3x minus 7 is greater than or equal to 5. Because this is a greater than, I have to set it up as an or. And how does an or look? Out. Yes? So, I got to set this equal to both negative and positive 5. So I'm going to start by remembering it has to be set up as an or, which means it's going to be everything less than negative 5, right? And it's going to be everything greater than or equal to positive 5. That would be an or. Look at my arrows, correct? They're facing like an or, aren't they? Okay, everything less than negative 5, everything greater than positive 5. Greater than or, greater, Gorland, however you want to remember it. And then you go about solving them. X is less than or equal to 2/3. Okay? Then you do this one. All right, now thank goodness it looks like I'm going to have an OR graph. If you end up with something that doesn't give you an OR graph, you did it wrong. So let's graph it, okay?
How do you know that it's going to give you an order?
Because I could just see in my head, x is less than or equal to 2/3. X is, we're going to graph it.
Oh.
But, all right, we're going to graph it anyway. 2/3, solid dot, x is everything less than that. And 4, solid dot, everything greater than that. So I ended up with an or. I'm good. This represents all the x values that would make this inequality true. We're not going to check for extraneous solutions with inequalities. Okay, only the equations. All right, so let's do this less than. Oh, it's a less than. So it's going to be an and, which means they have to be facing each other, correct? So I'm going to set it up as 2x minus 7, negative 1, and since it's going to be an and, I'm going to do this. See how these things are facing each other? And you always have the negative 1 on the left. It's going to be an and. Everything greater than negative 1, everything less than 1. That gives me an and. You visualize it, right? And then you solve it. I'm just going to give you the answer. X is greater than 3, and x is less than 4. And then you graph that. Here's 0, here's 3, here's 4, open circle, boom. That's an and. that number line represents every x value that would work in here and make this a true statement. Got it? Well, this is actually absolute, it's tolerance. So anytime you're producing something on a factory, let's say you're producing something on a factory. This is talking about a box of cereal, okay? It should have a weight of 25 ounces, but there's a tolerance of 1.2. What do you think that means? Okay, you could go up 1.2 or down 1.2 and it'll still pass inspection, okay? So they're wondering, well, what's the acceptable range then? Obviously, we could do it in our head, but we have to write an absolute value equation. So, write and solve an absolute value inequality that describes the acceptable net weights for the cereal in a family-sized box. So I'm going to say W is the weight of the box. So, whatever my box weighs, I'm going to subtract 25 from it and get the absolute value, because it's got to be a positive number, right? I'm going to take let's say the box weighs 26. I subtract 25, I got a 1 ounce deviation, don't I? You see what I mean? This has to be less than or equal to 1.2. So let's say your box weighed 23 ounces. 23 minus 25 gives me -2. If I take the absolute value, does it meet the requirements? No. So this is what you're trying to determine with an inequality. Okay? All right, if we solve this, it's a less than, so you're going to set it up as a what? Less than and, right? So we're going to do it like this. W minus 25 has got to be greater than or equal to -1.2, because I'm shooting for an and here, if you visualize in your head on the number line. These two are facing each other, right? And, okay? I'll just tell you what the answers are. 23.8. So the acceptable range is anywhere between 23.8 and 26.2. Acceptable would be, this does not mean by the way, it means between 23.8 and 26.2 ounces. Acceptable, let's just do that. Acceptable between 23.8 and 26.2 ounces. So this might, something like this, it's very basic. It's just kind of back to equations or inequalities here. What's different about this than what we were doing up here? It's got this +9. We can't set up this inequality until the absolute value is by itself. So this has to be by itself.
So you can just subtract the 9, right?
Right.
Subtract it out of it.
Mm-hmm. Before you set up the problem. Before Goreland. So you just subtract 9. You're gonna, yeah, they should make a video game. And then it's a less than, so you would set it up as an and you would go from there. You just, it has to be by itself before you can set it up. Okay? So that you can look back over the weekend at a couple of those story problems. I'm not going to tell you the third one. I can't give you all of them. Third one's not too bad. There is an extra credit problem. I would look through your notes if you're interested in that. Yeah. I don't know.
55.